So welcome to the Helix webinar series. Today's session is on service assurance and capacity optimization with AIOps. Today we're joined, Yaron and I, by Karen Hughes, our field sales manager and continuous optimization practice lead. And we also have Brendan Murray, our principal solutions engineer. So Karen, I'm going to get us started in a few minutes. I just want to remind our audience there is the option for the Q&A section of Zoom. If you have a look at the bottom, if you have any questions during the slides and the presentation and also the demo that Brendan will be doing, please put your questions in there, and we will have roughly 15 to 20 minutes or so at the end where we'll take some of those questions to the live Q&A. So I'm now going to hand over, Karen, for your formal introduction and to get us started.
Thank you. Hi, everyone. It's really nice to talk with all of you, and I appreciate the fact that you're joining us this afternoon or evening. My name is Karen Hughes, as it's been said. I've been working at BMC for over 28 years, and I'm a domain expert in continuous optimization. I have extensive experience in this space and have worked with a number of different customers in all kinds of industry verticals, and I'm going to share with you how capacity optimization fits in with service assurance and AIOps. I also have with me Brendan Murray. He's also been with BMC for over 20 years and is going to be doing a demo of some of the capabilities later on in the presentation. So welcome, everybody, and thank you for taking the time. To set the stage, this is session 9 of a number of different sessions that specifically focus on AIOps. So if you've attended any of these other webinars, you've probably seen this slide before. But what we wanted to call out is some of the previous sessions that Yaron Front had done and other individuals may or may not have done had focused on some of the required capabilities of AIOps beginning in the top 2 different sections, but we're going to focus primarily on the last 2 areas down here at the bottom under required capabilities, specifically around proactive capacity management and resource optimization. Ultimately, if you think about what is continuous optimization or what is capacity management, depending on what every organization says, it's ultimately the solution that's going to help be more proactive and predictive. It's going to help you become more operationally efficient. It's going to give you visibility across your entire environment or business services to ultimately know what is happening, what is going to happen, so I can potentially prevent any outage, slowdown, constraint before it happens, and then obviously link into all of the automation to also notify and inform of different things that happen. So that's in a nutshell where we fit when it comes to AIOps. But let's take another step back and say, if you are thinking about becoming more proactive and predictive, what kind of challenges do you have, or why aren't you there now? The fact of the matter is that most organizations are struggling with a lot of these challenges because as they start maturing out of the real-time monitoring event management arena, now they want to become proactive, but they're realizing that this is new territory, and to understand what to do and how to do it starts to get a little bit complicated. But the reality is you're not alone. And as you can see, there was a survey that was done that basically talks or asked a number of the IT decision makers, what kind of challenges do you have when it comes to capacity management? And ultimately, it centers around visibility, being able to do any type of prediction, and understanding what type of resource usage that you have across your organization. But ultimately, Nirvana is to really look at things from a business service perspective. So what is the overall health of my applications? And then thereby, what infrastructure is supporting those applications? And when am I going to have a problem? Because real-time monitoring tools only maintain a small amount of data for a short period of time. They're not able to do accurate predictions. And that's why a capacity management tool is complementary. It consumes the real-time monitoring data, but then it aggregates that and stores it in a data lake. So you can ultimately be able to do all kinds of advanced functions regarding doing predictive analysis and saturation prediction and what if modeling. If you think about what are the core competencies of capacity management, much to what I just mentioned, the challenges that organizations have. Well, your capacity optimization solution should be able to uh, fulfill all those gaps and solve those challenges, specifically by one, consuming performance data, raw performance metrics from a real-time perspective, business KPIs that are more centered around what are the applications actually doing. If you're insurance, it could be claims, it could be for banking, it could be number of transactions, those types of things. But you want end-to-end visibility across your complete environment. Otherwise, you're going to be in technology silos and you're not going to be able to get a full understanding of what resources you have, how they're allocated, how they're utilized, and then what applications are running on those resources. Then you have to think about, well, how do I get all that data? Well, you want to ingest the data, not put more agents down. There's plenty of agents out there with all the monitoring tools, because on average, organizations have anywhere from 18 to 22 different real-time monitoring tools. So we definitely don't want to lay down more agents. Let's consume that data that's already being collected, but then let's apply analytics. Let's apply machine learning. Let's apply AI onto that data to be able to do your forecasting, to do predictive analysis, to be able to do what if modeling. What if I make a change? What if I move into a hyperconverged infrastructure? What if I'm moving to the public cloud? What resources should I need? How do I optimize my environment to reclaim unmapped or underutilized resources to save money? How do I do more automation to become more operationally efficient? Those are all the different types of things that you want out of a capacity management solution, and which is what you don't get in real-time monitoring or performance management products. So if you think about what are the required capabilities for a capacity management solution, it's all about aggregating data, storing data, being able to be proactive with that data, and having the tools have analytics and Q network modeling on the back end to help predict whether it's costing, whether it's configuration, whether it's how to reclaim, and looking at recommendations for how you could save money by right sizing, deferring purchases, or even again making your teams much more operationally efficient so you can do more with less and ultimately become more successful and expand your business. So if you think about what organizations are trying to strive to, they want to accurately be able to forecast and predict something that's going to happen in the future, whether it's in the financial services sector, and now FFIEC compliance is a requirement where they're telling organizations if they're not going to create capacity plans, then they're going to get fined. Then organizations are saying, well, how do I do this? Because I don't want to be fined. But I don't necessarily have a tool that can do that accurate planning for me. And that's where continuous optimization or capacity tool helps you, because it has all that data. It can correlate performance data with business KPI data to accurately predict what an application or business service is going to do. And this ultimately helps you plan better, because then you can anticipate, well, if I know that, I have to plan for holiday readiness. I mean, we're for the United States, we have Thanksgiving next week. Organizations have to plan for an uptick in shopping behavior either the day after our Thanksgiving or the following week, where Americans tend to want to go shop more for Christmas. Well, that means there's going to be an uptick in transactions. There's going to be an uptick in hits to websites and things like that. So organizations want to plan, because if we go to Amazon.com and all of a sudden they've got 1,000 more users per hour hitting Amazon.com, and suddenly it says unavailable, under construction, 404 error, then those shoppers might say, oh crap, maybe I'll go to another retailer such as Walmart or something like that, and they'll lose business. So ultimately, being able to understand how your applications are running and what resources are needed for those applications, and then being able to understand increases in business demand and the impact of that on your applications and the backend infrastructure will help you do better from a seamless service to your customers and not have any outages or slowdowns, et cetera, and those types of things. Ultimately, this is going to help you mitigate risk. It's going to improve business agility. It's going to potentially reduce costs and certainly improve operational efficiencies. When you think about where you are today, organizations for the most part are still, if they're talking capacity management, are still focused on component level capacity management, which means they're operating in silos. Oh, my VMware team is looking at my VMs. Oh, my storage team, they're looking at storage capacity. Oh, my network teams are looking at network capacity. But that doesn't help put it to the big picture and look at it from a service perspective or an application perspective. So it's important that you have some type of discovery tool, whether it's a BMC discovery tool or someone else's, that can create and map your applications so you can see the topology. And then you want a capacity tool that's going to marry all of those performance metrics, those real-time performance metrics that you're collecting, marry that with that topology of those service models, and then ultimately you'll be able to get to business-aware capacity planning. And this just shows a journey as to how you can get there and what the difference is between component level management, service level planning, and business aware visibility. Ultimately, now organizations want to get to business aware capacity management. They want to be able to understand what is the overall health of my business services and applications. How are they performing? How are they trending? And then ultimately, again, what if something changes to my service demand because of open enrollment or Black Friday or whatever, so you can accurately plan and prepare so you're not going to have any outages and not lose any money and introduce any risk. If you think about what kind of use cases does this product entail, or should a solution entail, all of these different use cases, and there's roughly 17 of them, are about consuming data, understanding the data, aggregating the data, predicting or correlating the data, performing what if modeling or simulation on that data, so you can ultimately understand and get a better handle on your complete environment and the applications that are running. If you think about it, you might say, oh, I know that I'm fine with capacity planning because I know that I have, all these storage resources, and I'm sure I'm fine to support my applications. But if you don't know what your total capacity is and how that capacity was allocated, and then how that of the allocated resources, how are they utilized? And then more importantly, what applications are running on those different utilized resources, you're probably going to have some type of constraint where you've underallocated or overallocated resources, and you're going to have a potential problem. So number one is make sure you have that visibility, and then leverage a solution that has all the built-in AI in it that can automatically do your forecasting, can automatically predict when you're going to have a constraint, can predict what that constraint is, and how you can fix it with recommendations, so you can make sure you get ahead of it so the end user doesn't have any degradation of service. If you think about how does BMC fit in this space, well, BMC has been an expert expert in this, a leader in the market for the last 40 plus years. And we focus on, one, giving you the ability to connect to all of your different real-time monitoring solutions that are out there, consume that data through ETLs, and then be able to automatically populate into our data lake, and then display that type of data in out-of-the-box views, in charts, reports, graphs, etc. Then we'll give you the ability to look at it from a business service perspective or from the underlying infrastructure. We'll be able to optimize your environment to tell you where you can reclaim or better utilize or reallocate resources. We'll be able to model simulations to the public cloud. You'll be able to model going from one piece of hardware to another. You'll be able to optimize your environment from a Kubernetes containerization perspective. You'll be able to accurately do all your planning around seasonality or looking at things from a 1 week, 1 month, 1 quarter, 1 year. You'll be able to predict when you might need to purchase new hardware and where you should allocate that, and forecast when there's going to be any type of constraint. So there's a full gamut end-to-end capabilities when it comes to BMC and capacity management or capacity planning. So as we, you're probably done listening to me talk. You want to see it in action. So I'm going to have Brendan Murray come up and share his desktop, and he's going to go through not 17 use cases, but we're going to focus on these 5 different use cases, which are one, get an understanding of where you're at. So getting full visibility across the different infrastructure components, but also the overall health of your applications or business services. He's going to do a Kubernetes optimization modeling scenario. He's going to show you how we can automatically show you where you might be saturated and what recommendations are to alleviate that saturation. And then we're going to do a simulation of migrating to the public cloud from an on-prem environment for an entire business service. And then potentially do some what-if analysis on forecasts, where you can actually do a forecast and then put what-if events on that forecast and see how the forecast changes. So without further ado, I'm going to pass the baton to my esteemed colleague, Brendan Murray. Brendan, are you out there, and can you take control and take us on a journey to see the product in action?
I am here, Karen. Thank you. I'm attempting to share my screen at the moment. All right, so you should see my screen now with a minimum of other things in front of it. Does it look good?
Yeah, it looks good. Thank you.
All right. So yeah, so we Karen set up the use cases that I'm going to take you through. We're going to start at the top, which is the visibility and health of your business services. So our focus with BHCO, BMC Helix Capacity Optimization, is very much around managing capacity at the business service level rather than at the individual technology level. So that's where we're going to start with this business service overview. This is one of the out-of-the-box dashboards that allows you to get an at-a-glance view of the health of your business services that you're delivering to your users, to your customers. In this particular environment, we have 16 business services. We've categorized them according to how critical they are, and then we're monitoring them according to how heavily utilized are they. Are they saturated, meaning that the volume of work that they're getting is now exceeding the resources available in order to get adequate performance? So we've got a number of services that are currently saturated, and that's what's showing up in the now category. We've got a couple of critical services, in fact, that are in this category, which is not great. If we had services that were okay but heading towards being saturated, they would show up in these middle columns. And then we've got a bunch of services that are all green. They're not saturated. They have enough resources in order to do the work we're asking of them. Further down the dashboard, we can see what we call business drivers. And business drivers, if you think of the resources of your IT infrastructure as the supply side of the equation, business drivers are the demand side. They are the actual units of work that we are asking your business services, your applications to perform. So that could be processing invoices, it could be serving web pages, It could be handling visits to a website. It could be simply the number of concurrent users logged into an application. So we are not only are we pulling in the system level data from your infrastructure, but we're also looking into your applications and seeing what are they doing, how many pages per second are being requested, how many orders are being processed per minute, per hour, and so on. So we're looking at both the measurement of available resources as well as the measure of demand on those resources. And then we're saying, all right, given the resources we've got, what kind of growth can we support in those resources? So we can see, for example, a lot of these things are green, meaning that for visits, for example, the number of visits to this Acme billing service could go up 228% over the next 6 months, a year, whatever, and we would be fine. We have enough spare capacity in that business service that we can handle that growth. Whereas others, the Acme IT Global Service, we're actually already saturated. We cannot handle any more workload in this service because we're already using all of our available resources. And then we have a couple of other ways of looking at the data. We're looking at, in this case, this pie chart, we're looking at what percentage of our services are at risk. They're either saturated today or they're going to be saturated soon. And then we also have a look, we can break out our services into different groupings according to how heavily utilized they are. So we have quite a few services. Each bar represents a number of services and how heavily the usage measurement, which is essentially a percentage value. So we've got a number of services that are not heavily utilized. We've got a few that are pretty busy. And then we've got a few that are, we've got one service, it's probably saturated at this stage. It's in the 100% bucket. So that means we've got at least one service that we really need to give more resources to. So we can drill down and look at more detail at the business services. The business services are made up of a number of subcomponents, which is really the infrastructure, the IT infrastructure that's supporting the business service. So we group it into pools. So pools could be pools of database servers, application servers. You get to define how those pools are organized. So for example, Acme Billing, we've got a billing pool, we've got a web portal, we've got a back end, and so on. And we can analyze, from at the level of the pools, how are we doing in terms of which ones are saturated and how are they saturated? Are we running out of memory on the servers? Or on the containers? Are we running out of CPU and so on? Where is the actual bottleneck? So we've got a few services that are saturated today. And we can drill down even further into the services to get more detailed view of the current health of the service. Is there any risk? Just because there's risk doesn't necessarily mean the service is not in a good state today. It just means that there are parts of it that are nearing saturation or maybe saturated, but they're not impacting the overall performance of the service. So here we can see in the e-order service, these are our business drivers. We've got plenty of room. We've got supported growth numbers that are all in the green. But what if we wanted to see whether or not what our forecasted growth, what growth could we sustain in the future, in other words? So let's do a what if simulation to see how much spare headroom we have in our Acme e-order service and how it would be able to cope with an increase in demand. So I'm now in the simulation part of the tool. So I'm going to analyze, I'm going to simulate basically adding additional load on my Acme e-order service by increasing the volume of one of my business drivers. And what I'm going to pick is user visits. So today I've got plenty of room. I can support an additional 216% growth factor in my user visits. So I'm going to go and push it beyond that. And you can see I'm looking at the user visits, and we're actually trending downward. So where the application has been getting less load over the past few days, and that's why we're predicting a downward trend. I'm going to change that. I'm going to say we're having a marketing event. We'll call it cyber marketing event, online marketing event. And I'm going to say that I'm expecting an increase in user visits of around 700%. So it's going to be a heck of a marketing event, and I'm going to have that marketing event start on December 1st. All right, so I've now changed the projected growth of that business driver. I'm going to click on OK. And what's going to happen is the model of the business service is going to automatically incorporate that predicted growth. And it's going to tell me whether or not, based on the current configuration of that service, whether I can actually sustain that level of growth. And we can see here from the timeline, we're forecasting out 6 months. I could change that timeline, by the way. I could go further into the future if I wanted to, but we're going to work with just a 6-month horizon. I can see that I'm in the red, so I'm not actually I'm going to be saturated basically in 10 days, which is about the number of days between today and December 1st. So as soon as December 1st rolls around, we are not going to be able to support the volume of work that I'm modeling here. So we can look at, we've got actually problems in 2 of our service pools, the application pool and the web pool. And we've automatically created some recommended resizing options. These are what we call scale out, meaning that we're adding additional servers. The other option is to scale up, which is to increase the hardware capacity of the individual servers. So if we could add more memory, more CPU, or we can simply add additional servers to handle the additional load. So I could simply just turn these on and see how that impacted the performance of my business service. I can also, if I want more control, I can create these myself. So I'm going to say I want to scale up my web service pool myself. The recommendation is 3. Let's go maybe 1 more than that. We're going to add an additional server. And I'm going to do this on November 29th, which is 1 day before we're expecting that new workload. You can see if I wanted to do the scale up option, I could do that as an alternative. It's either or. So I could add CPU, memory, or storage as well, and increase the capacity of my service that way. And now I'm going to add, that's not going to be enough. We still also need to add resources to the application pool. So I'm going to do that as well. The recommendation is 4. Let's go 1 more just for an extra safety margin. We'll let it pick the date automatically. Again, the date is before we're expecting the new the marketing campaign to actually start, when we're expecting that 700% growth. All right, so now I've done a custom resizing, and I'm going to apply my changes. And the model will recalculate, and we can see that now we're back in the green. So the addition of these resources has allowed me to keep the Acme e-order service performing well, given the forecasted increase in load of 700%. So once I've created this, I can go back and we can see that the application pool and web pool are no longer saturated based on the increased resources that I've added to those pools. And if I wanted to save this for further analysis or review in the future, I could just go ahead and do that. We're not going to do that today, but that's essentially how we do what-if analysis at the level of the business service, so that you can understand if you are expecting an increase in the volume of work that those services are doing, you can model that and understand what you need to do in order to be able to sustain the adequate performance of your services. All right, so that was operating at the business service view. We can drop down to, actually, I'll switch into another tab here. We can drop down into the level. Now we're no longer operating at the level of services. We can manage our, in this case, we have a containerized environment using Kubernetes. And we can analyze our capacity, and we can do what-if analysis and modeling at the level of our Kubernetes environment. So we're looking at, right at the top level view, we're looking at the health of our clusters, how we're doing in terms of CPU use versus capacity, a number of other key performance indicators. One of the most interesting numbers on this table is the spare pods indicator. So that's based on the data that we've got in terms of how your pods are being utilized today. We can say, given current workloads, you have room for an additional X number of spare pods on your cluster. In this case, on the K8s prod cluster, we've got lots of headroom. We can actually add an additional 3,800 or so pods, and the cluster has the resources to do that. We can look at, rather than looking at just the cluster level, we also have a view into the nodes that make up our clusters and how they're doing. And we can see that everything is either in the blue or green range, indicating that we're not having resource issues at the node level. We can also analyze your Kubernetes namespaces in terms of, again, CPU request versus quota, CPU limit versus quota, and so on. So again, do we have the necessary resources? Are there any bottlenecks at the level of the namespace? And we have actually identified a memory bottleneck in terms of the AMSK2 namespace. We can look also at controllers, and at the level of the controllers, we are seeing more issues here. So we're looking at a different set of statistics at the level of individual controllers for different namespaces, for different controller types, replica set controllers, stateful set controllers, and so on. We can see that we've got some memory issues on some of our controllers. We've got some that are also having both CPU and memory issues, right? So we may want to look at adding resources at the level of controllers. We can drill down to look at pods as well, and we can look at recommendations. And really, recommendations are where the power of this solution comes in. So we can, if we're seeing potential bottlenecks, potential performance problems, we will automatically make recommendations in terms of what you need to do in order to be able to handle the demand on the resources of your Kubernetes clusters. So right now, at the level of the infrastructure, we're not seeing really any issues. So there are no recommendations at that level. However, at the level of containers, we are seeing that probably should be adding some more memory for our containers. We can see that in the number of controllers and pods, we have saturation. And so we can actually look at, in an individual controller or pod, we can click on that icon, forecasting saturation at the container level. We can look at recommended actions, and we can look, in fact, this is what our current configuration is in terms of utilization. This is what we're forecasting over the next 30 days and 90 days. And these are the recommendations that we're making in terms of reconfiguring at the container level, adding resources at the container level. And with these recommendations, we can save these for review, or we can, if we're satisfied that, yeah, we're not too worried about that at the moment, we can just click on ignore and then apply. And that recommendation, that entity, in this case, a container, will be removed from the list as something that we need to pay attention to. We could select all of them and say, I want to go ahead and save all of them for review if we wanted to do that. If we go and look at the cluster level, well, actually, let's go back to the container level. We can see also we can reclaim actually some CPU based on requests versus recommended CPU. So we have actually additional CPU available at the container level. We also have reclaimable memory at the container level. And again, we can look at the details of that. So this is about getting resources back rather than avoiding saturation. So right-sizing your environment, in other words. Right. So again, we can look at the details of the recommendation, and we can, if we wanted to, not only can we save for review and ignore, but with these particular recommendations, we can send the recommendation to the automation component of our platform, Intelligent Automation, and Intelligent Automation could actually go out and make the configuration changes to your Kubernetes cluster in order to get those resources back. Finally, just like with the business service level, also with the Kubernetes level, we have the ability to do what-if analysis. So we can go ahead and at the controller level, if we wanted to do a what-if analysis, say we've got one that's currently green, but if we want to model what it's going to look like if we suddenly add some load to that part of our Kubernetes environment, we can, again, select our forecasting period. we could put in right off the bat, we could say we're going to forecast based on an increased load of X%. I'm just going to leave that unchecked at the moment, and I'm just going to say use the current organic growth that we're seeing in the data itself rather than adding an artificial percentage. So everything's looking good now. Now I can add an increased load factor to my Kubernetes cluster. I'm going to go really high to make sure that we actually get saturation. Let's again pick the beginning of December as when that load starts. And I can add that. And I can see that if I add that 500% workload, then this particular controller in my environment, the mid-tier user, is not going to be able to handle that additional load. So again, much like I can do with the business service, I can add resources. And again, I can scale out or scale up. So this time I'm going to scale up. And I'm going to, we're actually bottlenecking in memory. So what I'm going to do is I'm going to add more memory. We'll go up to 400% more memory, just to make sure we're adding enough. And we're back into the green again. So very similar to the what-if modeling we can do at the service level, we can also do it at the level of your Kubernetes infrastructure. All right, so the next thing I'm going to do is I'm going to move on to the migration simulation. And this is basically the way what this allows you to do is simulate migrating either your servers or your business services that are either on premises or are running in another cloud provider. And you can answer the question really, what if I move this from on premises into the cloud? What will that look like in terms of what will it cost me? What kinds of cloud resources will I need to be able to do that? So I can do that at the level of business services, and I can do it from on-prem to cloud, or I can do it from one cloud provider to another. I also, right now I'm looking at business services, I could do it at the level of individual servers as well. So if I wanted to just pick particular servers and say, how would I move? What would it look like if I move those into the cloud? I can do that. But I am going to do, I'm going to operate at the business service. And I'm going to take an on-premises service, which is my Acme eOrder service. And I'm going to go ahead and say, let's simulate moving that into the cloud. Right. And immediately what it's going to do is it's going to take the on-premises cost, and you're probably wondering, okay, well, where are those cost numbers coming from? Well, they're coming from your configuration settings. So you get to define based on your experience, what are the on-premises costs per physical CPU, virtual CPU, memory, and storage. So these are completely under your control. So I can go into edit mode, and I could go ahead and make changes to these on-premises costs if they're the ones that you get out of the box are not fitting. As far as the costs from the cloud providers, those are coming directly from the cloud providers. So we're importing the price catalogs from the various cloud providers that we're modeling in the migration simulation. So once we've got that data, so we were then calculating, okay, what would it cost to run this service in the various cloud providers? You can see the arrow is going to the Oracle Cloud, meaning that is the cheapest one by a significant margin. We are saving money no matter which cloud provider we actually go to. And so if I wanted to, if I was more of an AWS shop, I could pick AWS. And I'm looking at the cost savings for on-demand resources, as well as resources that are contracted in advance, so paid for in advance, essentially. Those, obviously, you get a better price on, but you are committed to, typically with most cloud providers, either a 1-year or 3-year term. So you get better cost savings, but of course, you have to commit to purchasing those resources in advance. I could, if I wanted to, I could play around with, we've automatically suggested which resources, which cloud instance types we are moving your on-premises application to. We're doing this using the utilization-based strategy. So that means we are actually looking at the utilization data that we've collected for all of these resources, and we've said, all right, what AWS instance type do we need in order to run that with adequate performance or acceptable performance in the cloud. We could go in and make changes. We could say, I want to use a different region. So if I'm in the US, I could go, rather than doing US East, I could do US West, Northern California. I could pick a different region because AWS's prices do vary according to which region you choose, or they can vary. The other thing to understand is because we're doing the utilization based, we can go in and we can look at, we can go in and edit this, the way the instances have been selected. So if you're not keen on the way the model is picking the new instances, you can actually go in and you can customize the cloud instances that you're actually moving your on-premises resources to. And so that's the other thing, of course, is in some cases it may not be cheaper to move something to the cloud. So we do have a service that's already running in Azure, our procurement service. I can go and simulate migration there, and you can see that it's actually more expensive if I move this service into the Google Cloud or into AWS. Our costs actually go up. So in some cases that will happen. Rather than going down, depending on where the service is running today and where you're simulating moving it to. So that's cloud migration simulation. And the key thing is, even if your resources are already in the cloud, but you're looking at, is there a way to save money by moving this to a different cloud provider? We can help you make an informed decision there by doing that simulation. All right, I think I'm nearing the end of my time slot, so I'll go through this fairly quickly. But the final thing we can do is I'm going to go now into the workspace. So the workspace is essentially if you want to get much more granular in terms of the way you're analyzing your resources and get into modeling and forecasting and doing advanced correlation analysis, then you can, rather than working at the dashboards, the views that we've been working in thus far in my demonstration, we can actually go into the workspace. And the workspace allows us to really get into the nitty-gritty of our data. I can look at my e-order application. This is the production instance of it. And I can look at the service pools that underpin that application. And I can actually go in and do some forecasting and modeling around those resources. So what I'm going to do is I'm going to focus on my database pool, and I'm going to add a new model, and I'm going to do some forecasting around the resources in the database pool. So I'm going to select my resources. I'm going to pick my database pool. Next, I'm going to go with a custom model. We don't have any predefined templates. I'm going to focus on memory utilization for this particular analysis. I will go with the out-of-the-box thresholds to indicate, when the service is going to be saturated. And I'm just going to go with the default name of my analysis and finish. Okay, so I've got a forecast of memory utilization. So that's the sort of the basic forecast. Now what I want to do is I want to create a prediction scenario, run an actual scenario simulating some additional load on my service. So let's go ahead and we'll do a forecast period of 4 months. And we're going to use the 6 months worth of history data as the basis of my forecast. We'll save that. And it's automatically running the forecast. I can look at the execution summary for my database pool, and I can drill down into the details of that. And I can see that the forecast, here's my actual data, here's my forecast data. It's all good. There's really very little anticipated growth here, so it's a pretty flat line. So in terms of forecast, the database pool is probably going to be fine for months. But what I can do is I can add a what-if event, just modeling what happens if some unexpected additional growth occurs in the demand of that database pool. I can put in this case, I'm going to go with a generic performance increase or decrease. So I'm going to put in a positive number. Let's put in 100 and save that. So I've now added a what if event, similar to what we were doing earlier with the other what if scenarios. We're now just operating at a much more granular level, at the level of a database pool. I can rerun my model and have another look at my performance graph. And I can see now I've got a problem. I've modeled an increase in load of 100% in demand on that database pool. And I can forecast that I'm going to need to add resources to that database pool if I'm expecting that kind of growth in demand. So that's another example of the power of being able to analyze and forecast based on expected demand on your resources. And with that, I will wrap up the demonstration part of the presentation.
I don't know, Karen, if you want to go back to the slides, we have got a resources slide just so we can talk those through, and then we should go to the Q&A. We've also shared out a poll, which I see some of you have already started to respond to. We've got a few questions. We just like to capture this so we've got the opportunity to look at where we might be able to help you with further improvements. So Karen, if you want to just take back the share to the final resource slide.
Sure. Let me just.
Thank you, Brendan. And keep the questions coming in, everyone. I know there's been quite a few questions coming up as we've been going through the demo.
Okay. Oops. Now suddenly I have all kinds of stuff. In the deck, what did you want, what's coming up?
Yeah, so we'll just go through after the use cases. So we've got, obviously, as we mentioned at the start, we have actually got this as a series. So don't feel that you can't go to one and not the other. They're all independent. We've just put them together as a series. So both Yaron and I work together on a monthly basis to bring different topics to you. And the connection is the AIOps theme. The next one we've got available, you can see with register here, and apologies, there should be a date on there. That's going to be the 4th of December. We will be sharing these slides out and the registration links, so don't worry about seeing them as hyperlinks. So please come and join us if you want to learn about Netreo. And then we've also got the past recording for our previous session to Karen's and Brendan's, which was session 8. You can get access to those. All of the content is put on communities. They're also, any recordings get put onto YouTube, so all of those links will be shared with you post-event. We try to get these out in the next 24 to 48 hours. There is also a short survey, so if you have any other topics or of interest around AIOps, please do fill it in, because Yaron and I meet regularly to have a look at the topics to create them, and we will be looking at building up some content for next year. So if we want to go to the Q&A now, the links for YouTube and that we'll share with everyone with the slides. So Karen, I know that there was a question that came up prior to here when someone registered, and I think some of the KPI stuff was covered, but someone was asking what are business KPIs and how should they get them into a solution? I don't know if you want to maybe talk that.
Sure. So business KPIs are really business metrics that kind of explain or help you understand how your applications are performing. And most organizations leverage tools like Splunk, or they have different types of repositories that they actually measure their data, whether it could be number of claims per hour, number of web hits per hour. Those types of metrics are what we're talking about when we're saying KPIs. And if you have a tool that collects that, this solution can connect either through an API, or if it's in a repository like a database, we can either connect to the database, or you can export it into a flat file like a CSV file. And then we can automatically use one of our out-of-the-box ETLs to pull in that data in. And that's how you would get the KPI data in. And why it's important is because that data we correlate with the raw performance metrics that Brendan was showing a lot in the demo. And if you think about, most real-time monitoring tools are going to show time series data. Correlation graphs, which are really important to understand changes and impact of how business KPI or the applications affecting the underlying hardware, if you do that in a scatter plot view, it's going to be much more insightful. And a lot of that first use case that Brendan showed of the business service view, the back end on a lot of that has to do with looking at KPI data correlated to performance data. So I hope that helps.
I would just add one thing to that answer, Karen, which is business KPIs and business drivers are the same thing. We use the term business drivers in the initial part of my demo. In that business service view, it calls them business drivers, but they're the same thing.
Thank you for explaining that, Brendan.
Sure.
Okay, we don't have any questions left in the Q&A, but I want to open the opportunity for those that are still on the call. I'm just going to unmute you. If you do have a question, please raise your hand or come off mute.
Yeah. So Sam, we did get one question before this session, which is, I'm planning to move from using VMware to another virtualization solution. How can I use this tool to assess the best way to do that? Will I see the actual VMware usage so I can better plan what I need after switching to another provider? So maybe Karen, you can address that.
Sure, it's a great question. A lot of organizations are, because of the fact that Broadcom had acquired VMware, are looking at potentially scaling back their VMware footprint and moving either completely off or in a hybrid approach. And even BMC has done that too. This tool is perfect for that because, again, it's a planning tool, right? So this tool can help you plan, if I were to migrate off of VMware or partially off of VMware to another product. First of all, you would ask yourself, where would I go? And the market pretty much is settling on either Nutanix. If you look in CIO Magazine 2 weeks ago online, you'll see there's a big article from the CEO of Nutanix saying his business is booming, or Red Hat, OpenStack, or OpenShift. So the cool thing is that with this product, since we are heterogeneous and vendor neutral, we can support looking and migrating and helping you plan for any technologies, which includes, either Nutanix or OpenStack. And we help you plan. And then more importantly, we have out-of-the-box views for both Nutanix and OpenStack to show you exactly the visibility and recommendations and hierarchical structure, if you will, of your environment, much like we currently do today and with VMware. You'll be able to see the same type of capabilities with Nutanix or OpenStack. And so you can have the same tool to support your environment, regardless of what tools you have. And that's the nice thing about this solution is it's very complementary and can grow with you. And if you start changing tooling and vendors, we can support all of them that you have.
Great response. We have another question for Alejandro in the chat. It says, in your experience, the client's still using TSCO agents, or are they more like to be discontinued?
No, I still have a handful of customers, especially my big financial institutions, that still love what we call capacity agents, right? Those are still supported in our Helix version and will continue to be supported. They also are required if you want to use the investigate capabilities that have been migrated into Helix today, as well as needed for any workload characterization that also has been migrated into Helix today. I don't foresee them going away, but Ryoron could answer since he's product management.
Yeah, thanks, Karen. Yeah, so we still maintain all of our capacity agents in BHCO. Right now, we're actually enhancing a lot of these services, and we don't see these agents going away anytime soon.
Okay. Sounds good. Thank you. Well,
Thanks,
Thank you,
Alejandro.
Alejandro. Okay, that is all our questions. I'll just ask once again if anyone has any questions, like Alejandro, if you want to just come off mute. We've got a couple more minutes left.
You don't have to be shy. We promise we don't bite, but also know that if you do have follow-up questions, all of us are here to help answer. You could always email us or call us, and we'd be happy to have a much more further in-depth conversation with you as well.